This year's grand award winner is the replacement of structures over Great Egg Harbor and Drag Channel. This replacement of structures on the Garden State Parkway at milepost 2728.8 is an all-concrete structure from tip of the massive 30-inch square concrete piles to the surface of the 70-foot wide deck surface and everywhere in between.
In May of 2013, the authority awarded a contract to a joint venture, Route 52 Constructors, to totally replace the existing Great Egg Harbor Bridge and the drag channel structures.
The first phase of the program was to replace the aging southbound structures with a new structure you see behind me.
2 bridges, 800 feet over drag channel and 3,800 feet over the Great Egg Harbor Bay. It's 20 piers, 70 foot wide over Egg Harbor, the main structure, with retaining walls on Drag Island, supporting about 1,400 foot of fill, and retaining walls at the abutments to support the approaches.
Our piles ranged basically from 80 feet to 130 feet. There was a test pile program done at the beginning of the project, and we drove piles 150 foot in length and drove them to their full length to help identify the supporting strata in the ground. And that information that was collected turned out to be the basis for the rest of the piles driven on the project.
Our footings are sitting on somewhere around 65,000 linear feet of piles consisting of 24-inch square and 30-inch square piles. I mean, if you look at those numbers, that's somewhere around 12 miles in piles that's in the ground and somewhere around 7 miles of new girders that's in the ground.
Most of it really came in on a barge from Bayshore. So getting the barges loaded in Virginia up to the site and offloaded in time, and the right product too. It took a lot of coordination with Route 52 and Bayshore to get that done right.
I was concerned while we were building this bridge about seismic vibrations and potential damage to the existing structure. So we're driving 150 foot, 30-inch square concrete test piles with little seismographs hooked to the existing southbound structure to monitor any vibrations.
So the uniqueness is the length of the spans. These are the longest pre-stressed concrete I-beam girder spans that we've done, and actually the longest ones in the state. Normally when you get up to 180 foot and 250 foot in the channel, it's usually steel girder design. This, we kind of push the limits of using pre-stressed concrete I-beam. That works out well in the marine environment, and few less piers in the water really helped with the permitting process.
To get the concrete to the job site, thankfully the plant was close, it's in Pleasantville.
We had to pull trucks from other locations at times. We had to schedule day shift guys, night shift guys, try to keep our regular customers happy during the day and still keep Route 52 constructors happy at night.
But we still had to deal with traffic, especially in the summertime tourist season. You couldn't do your pour at 2:30 on a Friday afternoon. That wasn't going to happen. There was no concrete plant on site. All the concrete that was poured in place was delivered in ready-mix trucks. Some of these footers at Pier 8 and 9 are 800-yard pours. They were poured continuously. We had to manage the cooling and thermal efficiency of the concrete so we didn't get cracking.
In the wintertime, we had to use our boilers, make sure that we're heating the water up to maintain a minimum. We're shooting for 70-degree concrete temperatures in the winter. Summertime, basically the same. Mass pours, 800-yard mass pours, we were targeting 72 degrees placement, which was a challenge when you're talking about 85, 90, 95-degree ambient temperatures. To combat that, we had to use ice, manually add ice to the trucks before they would get loaded, sometimes up to 100 pounds per yard. On an 800-yard pour, that's a lot of bags of ice.
We tried to pick actually bad weather days to pour, where it was overcast and cool. Those were better days to pour than when it was 95. And the biggest thing we had to do was work with concrete supplier, Clayton Concrete, to pour at off-peak times to accommodate the number of trucks required, to accommodate the number of yards per hour. Minimum is 40 yards per hour on a deck pour, and to accommodate weather and traffic and everything else. It was really schedule driven.
In the admixtures in the HPC, it has a low water cement ratio, so we would combat that with super plasticizer. This way you can get the workability and the slump out of the concrete that you're looking for, but not jeopardize a water cement ratio or any strength issues.
We were able to use long, heavy girders that can be barged to the site.
So the bridge is 6 units, and Unit 3 is the post-tension splice girder section over the navigable channel. And that is a pretty unique use of concrete, pre-stressed concrete with post-tensioning to allow for 250-foot spans. So that is piers 8, 9, and 10 have pier segments set on top of them. And then spans 8, 9, 10, and 11 are 95.5-inch girders with 4 post-tensioning ducts running through them. And once they're all set on specially engineered support towers that Route 52 Constructors, with the help of McNary Bergeron, our outside consultant, designed these towers to hold the weight of the concrete. Then we had to pour these closure pours that locked all the girders together, run the post-tensioning from end to end and pull on it before that unit could stand up under its own weight and achieve strength. Then you poured the deck, then you ran another 2 tendons end to end, 920 feet, pulled on them, the deck then achieved full strength. So it couldn't even stand up under its own weight until we got it post-tension.
So if you can imagine trying to get the girders up without being able to do the flanking segments until we got the girders up, did a portion of the post-tension, got the deck up, did more of the post-tension, finished that portion of Unit 3, and then had to do the closing flanking section. So that was a challenge that drove the contract's critical path from design. The designer knew it and staged it that way. The contractor knew it and built it that way.
So the structure was designed by Hardesty and Hanover, and the means and methods to achieve the final results was up to the contractor on how to support the structure during construction.
The girders are built with 8,500 PSI design strength. You know, a few years ago it wasn't being used. It's gotten pretty common now. The pre-stressing strands is quite a bit of pre-stressing inside the girders. The longer the span, the more pre-stressing you need, and pre-stressing is steel strands that are cast inside the girder. They're tensioned under extreme force, they're stretched. The girder concrete is poured, and then the strands are released, which in effect, you know, puts compression in the concrete.
It's also something that pedestrians will be able to use. The structure has a 10-foot multi-use path that pedestrians, whether on bicycle, on foot, whatever mode of transportation they want to use, it'll give them a recreational connection.
There's a bump out that we call a fishing pier that will allow those individuals that would like to fish or crab to, you know, drop a line into the drag channel.
It'll be a connection between the two communities, and you'll see it grow and it become a very popular space.
The contractor contracted with DGI Menard, who designed and installed their product, which is called Controlled Modulus Column, CMCs, new technology, less intrusive, less disposal of unsuitable material, and that made a big difference in getting this job done and eliminating any settlement in the approach roadways. We have over 5,000 linear foot of MSC wall that we had to build, you know, which also accounted for about 42,000 square foot of precast concrete panels.
We had to coordinate with Menard in order to get all our details correct with how our soil mats were going to interact with their CMC system that they had, and they had layers of geotextile and fill that went up inside of our MSC wall up to the first strap. So there was days we'd be running over 10 loads out there for MSE walls and barrier and Jersey barrier. At night we could end up doing 25 loads in a night.
A project of this size comes with a very wide range. I think we had somewhere between 20 and 30 subcontractors on the project.
More than anything, our people is what got us to where we are today.
The credit goes to Route 52 Constructors, who put together a tremendous team, their own employees, all the union laborers, all the class of laborers that came out here, iron workers. The whole labor force came together, supported this job throughout. All in all, you have to give credit to the contractor, the authority, the design team that really did come together as a team and make things happen, even under some adverse conditions. The project was bid at just about $130 million. We'll finish up somewhere a little over $140 million. Work had to be scheduled around tides or winds. There's a sandbar in the middle of the bay, so it's not as easy as just getting out on the water and doing what you want. There are a lot of influences that really impacted his schedule, but he did a good job of planning for it and working around it. We are completing on time and structure is open to traffic.
Overall, the challenges of such an enormous concrete project were met through solid initial design and collaboration of the project team to deliver a signature structure for the owner and an essential piece of infrastructure for the community. Congratulations are certainly owed to this year's New Jersey ACI Grand Award-winning project.